Hello viewers, you are welcome to this video lecture. I am here to present the 20th video lecture from chapter 6. Chapter 6 deals about the drainage and drainage structures. In the previous videos will be deals about the importance of the drainage. So highway drainage structures are essential component in the design of the highway. Also deals about two type of drainage structures. There is surface drainage as well as subsurface drainages, and also will be deals about the inadequate drainage systems is very serious damage the highway structures, reduce the pavement structures, the traffic operations problems, and also will be slow the traffic movement is the cause of inadequate drainage systems. And also will be deals about the type of data needed to design the drainage structures. The first is topographic, channel characteristics, hydrological data, catchment characteristics, precipitation, flooding data, high water information, and existing structures is very important data to design the drainage structures. We discussed in the previous videos. Now will be deals about the surface drainage structures, and the one is flooding estimations, and also will be deals about the hydraulic design of surface drainage structure. For example, it is open channel or culverts discussed in this video. Surface drainage means by which the surface water is removed from the pavement and the right of way of the highway. So this is a properly designed highway surface drainage system. There is effectively remove all surface water or runoffs, direct these waters into the designed channels or gutters. So after the design channels and gutters, lastly will be the natural waterways will be joined. The waters seeping through the cracks in the highway riding surfaces mostly will be very serious problems related to the pavement structure will be decreases. Also will be there is defects, for example pothole cracks will be very a serious problem. Will be the surface water will be managed. Many major source of the surface water is surface runoff related to the rainfall. The surface drainage structures include the first is transverse slopes, so mostly will be provide on the pavements. It is camber, and also will be include the crowning of pavements. So the from the center line, the edge the slopes is downwards. Mostly it is provide 2.5 percent is provide for the traffic lane, and also crowning of shoulders away from the pavement. Also will be the shoulders also provide the slope, mostly 4% for pavement. So this will be a transverse sloping system. Longitudinal slopes will be provide a minimum gradient in the longitudinal direction of the highways. Mostly will be called as a ditch. So the slopes in longitudinal channel is greater than not less than 0.2%. So mostly will be in Ethiopia. Iran manual is provide 0.5%. Longitudinal channels also it is channels will be related to the ditch construction. So the ditch constructions will be collecting the waters from the cambers and also the longitudinal drainage systems, so into the ditches, so collecting the waters from the pavement structures, and also will be collecting from surface drainage to the to the right of way. So the water collecting by longitudinal ditches is then transported to the drainage channels, and then to the natural water ways also will be very important. And also curbs and gutters are very important. Mostly will be the facilities mostly will be related to the urban areas, particularly in residential as well as in commercial areas. And also there is cross drainage structures. These cross drainage structures are constructed to carry traffic over the natural waterways that flow below the right of way of the highway. So mostly the crossing structures will be provide major structures and minor structures. Major structures will be a bridge, large bridges, or a multiple span culverts. So mostly the major structure will be the span length is greater than 6 meters. Minor structures will be including small bridges or culverts, mostly less than 6 meters. And sedimentation and erosion control is also very important. So this is a continuous flow of surface water over shoulders, side slopes, underlined channels often result in soil erosions. So this will be controlled or prevented by the following methods. The first is anticipating drainage at the top of the cutters to collect and transport runoffs. And also curbs and gutters will be provided used to prevent unsurfaced shoulder and embankment slopes. And also turn covers on the unpaved surface shoulders, ditches, embankments, and cut slopes mostly will be provide flatter than 3 to 1. So this will be suitable for grassing. We have plant this in these slopes, so the sedimentation, also the erosion will be decreased. And also the design of surface drainage systems for highway may be divided into three phases. The first is estimating the quantity of the waters. It is related to the discharges, flooding, intensity, concentration. Also will be estimate the overall quantity of waters. And secondly, the hydraulic data of each element of the systems will be provided. So this will be the widths, the slope, the height of the ditches also will be related to the hydraulic design. And lastly will be two or three types alternative systems of material will be used. So for example it is concrete, for example it is masonry. So many materials or alternative material mostly will be economical material will be used. So mostly will be advised to be used local materials. And we have estimating the overall quantity for the design is the first is flooding. The flooding is estimating the quantity of runoff for drainage structures. When the drainage structure is to be handle the flow of an existing systems, for example it is a culvert or a bridge. So we have design based on the available records. the past flooding history also very important for gauging and also return period. So in return period means it is the frequency of the event will be coming. So for example is for we have collect the information. There is the returning period of the flooding will be 25 years. So design with 25 years. We have considering our 100 years. It is more than the uh, current information, so there is not economical. We have low the returning periods will be, for example, there is 10, so the material cost will be low, so there is the flood will be coming, there is a structure will be removed or out of control. So there is very critical for returning period. There is not greater than the this value or lowering the returning period. Rainfall intensity during the design storms is a function of occurrence, duration, intensity, and it is very important. An accurate estimation of the probable intensity, frequency, and durations of rainfall is particular location can be made only if sufficient data have been collected over a period of time. So for example, this will be see on the graph. So the graph will be the rainfall intensity, it is in millimeter per hour, and also the duration of time, the time of concentration. So we have T means the returning period. The returning period will be 5, 10, or 25 years. So we have considered the year of returning period. So and also will be this one is a runoff coefficient. Mostly a runoff coefficient will be C. So we have get the discharge is equal to the runoff coefficient times the intensity times the area over 316. So this coefficient of runoff will be related to the slopes as well as the type of the area. There is paved area. The runoff will be greater than more, for example, 0.9. When the area will be forest, there is 0.2. So we have decreasing the runoff depending upon the type of material. So we have calculating the discharge. So the discharge will be gained by the catchment area times the intensity times the area over 316. The time of concentration is time required. So from the surface runoff from the remotest part of the drainage basin to reaching the point where the drainage facility is located. It depends on several factors, including the sizes and shapes of the drainage area, the type of the surface covers, the slope of drainage catchments. The intensity is very important to design the time of concentration. So traveling time is mostly related to the first method will be the flow length over the average velocity. So mostly the velocity will be the distance over time. So we can calculate that traveling time by using the length over the velocity of the flow, so kilometer per hour. Also we'll be getting the traveling time for a section I, and also will be calculate the time of concentration. Also will be the summation of those sections. So the first section is forest, the second section is flat, the third section is with paved. So there is different cross section, so the catchment, so just catchments have their own traveling time. So and also will also be the time of concentration will be calculated by Kripke formula. So traveling time will be 0.87 times L will be the length square over 1000 times S. S is the average slope of the mean slopes. And also we'll be calculating the rainfall intensity. So this rainfall intensity will be gauged by A over B plus T. T will be the rainfall durations over the power of n. So A, B, and n will be the constant will be determined. So the runoff coefficients will be not the same for all areas. So for example, the area will be a flat area or a paved area. There will be C will be 0.9 times the area. And for example, the catchments will be forest 0.2 times the area. So the final will be the representative value, or runoff coefficients will be gained by summation of each segment times the area over the area will be gained. So we have summation, we have give the final representative catchments. And also very important part in this section part 2 is hydraulic design of surface drainage structures. So this is the objective of the hydraulic design of any highway drainage structures is to provide suitable structural sizes that will be economical and effective disposal of the expected rainfall without there is no erosion or sedimentation problems. For example, the first designs for side ditches. So when is the quantity of water expected to be reached at a given point in the drainage systems will be known. So principles of the flow in open channels also will be applied to flow in conducting with free water surfaces. And also will be the design of open channels is important design consideration in the flow velocity. The flow velocity in the channel should not be low at to cause depositing of the transporting material, or it is high the slope it is erosion. So the flow will be very important. So the slopes will be high, there is the flow velocity will be increased, and the bed of the material will be eroded. For there is a slope is very low, there is sediments will be accumulated, so the flow will be decreasing. So very important part will be adjust the slopes related to the flow velocity. For most types of laning or the beds of the ditches, sedimentation is usually problems. Slopes are less than 1%, and where there is occurrence of the erosions, the percent is greater than 5%. So the slopes will be, the bed of the slopes will be between 1 and 5. Considerations of recommended maximum velocity can be found at different standards. Related also will be literatures for be in different ways. So the for the hydraulic designers for open channels will be first will be calculating the discharge. The discharge will be A times V. So A means the cross-sectional elements. There is, for example, there is trapezoidal, rectangular, circular, different type of open channels. So times by the mean velocity, the adjusted velocity. The adjusted velocity also will be gained by r square, the hydraulic radius, times by the slopes over the n. N means the mining roughness coefficients. This mining coefficient will be, it is empirical, or will have, it is a given value. So this roughness coefficient is related to the material of the beds. Critical depths is defined as the depths corresponding to the charge from Tankan to rapid flows. So this critical depths will be calculated by Q squares over G will be related to the acceleration due to gravities and the area of the cross section over T. So T will be the free water surface. So the design procedures also will be a simply design procedures for mining equations will be, the first is for the covering material in the ditches will be running, selecting the mining roughness coefficient. So there is calculated using the mining formulas, calculate the maximum permissible hydraulic radiuses. The R value will be calculated in the given calculations using the equation of continuity. The minimum perceivable cross-section areas required for a given discharges and permissible velocities. Solve the expression obtained in steps by the bottom widths of the ditches and the depths related to the discharge. Calculating the depth of flow is very important. So the depth of the flow is greater than the critical depth, not less than for a critical depth. So it is will be calculated. The depth of the flow is greater than critical depth, so it is very important. There is also will be provide free borders. It is for safety of factor. If the depth is less than the critical depth, considering should be reduce the slopes and to be protect it from the erosion. And also design for the culverts, it is also very important. There is different cross drainage structures, fords, drifts, culverts and bridges. Fords will be a simple river crossing, so this is not able to carrying vehicles. It is slow moving water courses. There is almost no flooding. Drifts are crossing structure like fords. It is more by constructing by concrete slabs. The bed of the rivers is not able to carrying vehicles, for only for the pedestrian crossing. Culverts will be very important structures for the crossing drainage structures. It is water from streams and side channel below the roads. So the differentiate between the culverts and the slopes is there is by the basis of span length. So the span length will be less than 6 meters, it is a culvert. It is greater than 6 meters, it is a bridge. The principles for a culvert location is also very important. The majority of culverts are installed in natural water courses that's crossing the roadway. So it is mostly it is right angle or skew. So mostly recommended alignments will be it is 90 degree or perpendicular to the uh, center lines. So there is a skew, there is additional amount of cost will be invested. So related to cost, we have more recommended is right angle. And also select the proper locations culvert crossing with respect to the center line of the roads. Alignment and grades of the culvert is very important, and the alignment of the culvert should be generally conform to the alignments of the natural streams. So it is possible, if possible, we use a right angle. It is not possible, it is used some angles, so it is a skew culverts. But the economical interest of economic will be provide for the right angle. And also the hydraulic designs will be first steps will be the design hydraulic design should be adequate and economical without any erosion as well as sedimentation. Hydraulic designs will have the following steps, like the open channel. The first is obtain or the site data will be collected. The 8 data will be collected. Estimate the culvert invert elevations, culvert lengths, and the slopes also will be very important. And also determine the allowable headwater depths, or very important related to flooding. So the flooding will be high, so the height of or headwater depth will be increased. Select the type and the size of the culverts related to the flow. Examine the need for energy dispatches, very important for decreasing erosion or also sedimentations. Culvert types, there is different type of culvert types will be construct by using different materials. The first is reinforced concrete, mostly will be reinforced concrete, and corrugated metals will be used. So for and also will be using by timbers, cast iron pipes, and also masonry. We have different materials. Reinforced concrete pipes will be mostly used different diameters. For example, is uh, 13 centimeter up to 316 centimeter in different lengths. For example, 1.2 up to 2.4 meters in length. And also will be used in elliptical, circular, arch, in different size will be constructed by using reinforcement plus concrete. Concrete box culverts is also used in these cases. So mostly it is a square or rectangular in shape. So this will be, the squares will be 0.6 up to 3.6 meters size. Concrete arches also will be used in arch concave parts. Corrugated steel is always very important in highway drainage, and also corrugated metals also will be, the diameter is 20 centimeter up to 244 centimeters, mostly used 6 up to 12 meters in length. The other material will be masonry, stone masonries for in arches, and very important part is culverts. We have coming, the last parts will be highway bridge. This term of bridges will be very important for carrying the over an established waterway. The first one is water to cross the waterway or as obstacles, and also will be provide for a great separation structures, as we'll discuss in the interchanges. Interchanges are grade separations for elevated highway also we used. So these bridges will be mostly is the span length is greater than 6 meters, and also will be the ideal location for mostly a bridge crossing is right angle to the center line, not skew. So there is a skew, there is additional interest of economic will be increase. It is the stream will be narrowest point. We have decreasing the span length, so there is decreasing the span length. The investment of economy money will be decreased, and the alignment will be straight, not skew. If not possible, it is slightly or up to 3 degrees. Soil locations are adequate. Many times our alternative locations of proposed bridges will be some what similar advantages. And also we have selecting the final decisions of the alignments will be the traffic is related to the traffic safety and operating conditions, fulfillment of purpose of the roads, economical will be considered. The vertical clearance of the highway bridges mostly at least 4.3 meters, and main highway there is a clearance, a vertical clearance will be 4.9, so it is related to the vehicle heights. Thank you for listening my lecture.